So this is the second portion
Shout out.
of our mini lecture series. And it is single replacement reactions. Now, here's what I want to share with you on single replacement is that it always runs with this puppet show. A single thing and a compound. Yes? Always. Now, what the single thing is determines what type of, where we look on our activity series. Our activity series,
Probably give our activity series here. We may need you to show the group in a little bit. Now you can see.
now, down the left-hand side of your activity series is a list of all the metals that are involved. And understand this, a metal can only replace another metal. Here's what you're on your computer for. Only her. Thank you. You look confused. So, if you have a single metal sitting there by itself, it's going to look in the compound, try and replace another metal in there. That's scenario number one. Scenario number two, the single thing by itself is a halogen. Now, take a look at the bottom corner of your table. Let me show you the table here. The bottom corner of your table, you see how there's a unique list of just halogens. Now, I'm going to show you something here because this is an example that I saw a few students have issue with. Let's say you see this, fluorine plus lithium chloride and air. Now, when we're trying to figure out what the heck we need to do here, we look at the single thing here. Is that part of the list of metals? Yes. No. How yeah, we can look down the list, you're not going to see fine fluorine in there. Which means, what is fluorine going to try and replace? The chloride or the other halogen in there. Now, I have seen this abomination a number of times because what people do is this. They put their finger on fluorine and then they find lithium. And they look at lithium in the metals and lithium, the very top thing on the metals list. And they're like, well, there's no fluorine on that list, but clearly lithium is way stronger, so no reaction. Or even worse, I don't know how they get to this. They decide they're going to put fluorine and chloride together. And they make fluorine chloride thing, and lithium's all like, what? What just happened? And it's sitting over there by itself. Here's what you need to be aware of here. Yes, lithium is the most powerful of all the metals in terms of its reactivity or its activity. But fluorine isn't trying to go after lithium, it's trying to go after chloride, right? And chloride really is chlorine, part of a complex, we name it I. So this is the beauty of this. It's kind of like being in a competition where there's only 4 places, right? I mean, if you're top 3, you're getting a medal. If you're 4th, well, great. That's really sad. But if you take a look at it, goes fluorine, chlorine, bromine, and iodine, right? So if you put your finger on fluorine, it's a completely different hierarchy. Is fluorine higher than chlorine? Yes, chlorinated. So in this case, fluorine come in, knock out chloride, and take its place. That means the compound's going to be what? Fluoride. Lithium fluoride. Now, I'm delighted that I heard fluoride, a number of you here, and not lithium fluoride, because it's fluoride when it's by itself. It's fluoride when it comes to the compound, right? And doesn't chloride, which is part of the compound, get knocked off? And now it becomes chlorine because it's now by itself. Yeah? That's actually a big deal. So what it is with in a compound is a little different than what it is by itself. So now let's get into the actual formula right here. And this question is again division. Anytime you have an element by itself, that's the element, not the ion. Right? So that's fluorine, fluorine right here, that's not F minus. It only becomes F minus when it's part of our compound. So it's going to be at very worst as fluorine is an F. But you can write a single element. Do we do the Brinkelhoff test? Yeah. The Brinkelhoff test is it part of BRINCL, right? HOF. In this case here, it is. So we'll write doesn't F2 plus. Now we get into just writing the ion from this. So would that become LiCl? Li plus Cl they react to each other. And then over here, again, if you're wondering what I'm doing, I'm literally going, this is Li plus, this is F minus. We're grouping together, it doesn't become LiF. Plus chlorine. Doesn't it get knocked out by itself? Similarly, isn't it Cl2? Now, what I students do occasionally, and this really is troublesome, is they go, well, it's an F2 here, so it should be an F2 here. No, it's an F2 here because it's by itself. What happens on this side stays on that side. We look at lithium fluoride and we write it based on its charge below. Can I get above here with me on that? Now, this is definitely not balanced, agree?
Yeah.
So if I'm gonna balance, I'm gonna guess just going off the top of my head, it's gonna go like this.
Yeah.
2, 2. I can go through that, but literally all we're doing is just balancing by using coefficients. So this is an area when halogen by itself, sometimes make mistakes. Now, let's get to the part where we have to use the words on the page. We went over this briefly on the last page. I'm going to do it more intentionally right now. So let's say I gave you this. Let's say I went.
Wait, was that a single?
All these are single places. All these are single places. So let's say I gave you this. Let's say I went. Give me something from the second group.
Magnesium.
Magnesium. The front part of the since we did it, it's the same. All right, we're gonna go magnesium plus steam.
Ooh.
Now, I'm making deliberate right now. Actually, no, I'm not gonna be deliberate. I'm gonna go magnesium plus water. So let's take a look real quick. And here's what you need to be aware of. If you ever have a water or an acid, and you have a single thing, and then you have a water and acid sitting next to it, you've got to look at the words that are written to the side of wherever that thing is located on the field. So if you right now put your finger on magnesium, right? Does a magnesium, if you read next to it, say, can react with steam and acid doing what?
No reaction.
Replacing hydrogen. Well, in this case, let's make a distinction. Water versus steam. They're both are H2O, right? But water is liquid form, steam is water as a gas. Why does it matter? And if you notice here, as you go down the table, things become less reactive. So look at the top group. It doesn't it can react with water and acid reflecting hydrogen. So if you're in the top group, you can do everything to the left of you or to the right of you, and also things down below. So in group 2, you can react with steam, but water, you may understand it. You realize that steam is hotter than water is. If you want to get yourself, I probably would recommend doing this, but if you want to get yourself a good burn, get yourself in and boiling water, right? You're like, ooh, this is not, right? But if you want to get yourself a burn with higher temperatures, you're like, you know what? Yeah, this does the trick. I'm going to have to go to the emergency room. But if you really want higher temperatures, do you realize that water can go up to 100 degrees Celsius, whereas steam can go indefinitely higher. So if you have a kettle and the steam that comes out of it, right out of it, and you put your hand on top of that, now you're getting the high temperatures you crave, right? And you're burning yourself terribly. Please don't do this. I'm not going to have to have a trial later on for you being really dumb. Do not put your hand over a spigot on a kettle. But what you'll discover too is as you go farther up, you realize the air starts coming in, and so it becomes more dispersed, which is why you have this death zone above your pot. The closer you're down you are, the more steam capacity. Now, why am I sharing this with you, aside from the horribleness of that thought, is that steam, the product is moving more quickly. And when they move more quickly, they're more apt to react to something. So if something is less reactive, reacting with steam is more likely than reacting with water, which is cold. Does that make a lot of sense? That's why group 2 reacts with steam but can't react with water. True story? Now, what if I had said instead, since I have the ability to magically erase them, what if I said steam? Well, lest you get confused, I want to invite you to understand that steam and water and ice are all H2O. But what I discovered is that when we're doing the single replacement reaction, writing H2O does not really help us to figure out what we need to write. So here's what you can do. If we're actually the formulas first, so you can see this, write Mg or magnesium as Mg, and then write steam or water, write it as HOH. If you're writing HOH, it'll really help you in trying to figure out how do you separate things out. Huh. We had this conversation, right? This video changed out for you. Oh, what's that?
It was water. Would you write no reaction?
You'd write no reaction. So I should have paused it. If it had been magnesium plus water, we would have written Mg plus H2O. We want to stick those things that are actually trying to react. And on the product side, we've written no reaction. Is that like a comfort balloon that like goes like a
like a certified, like, instead of an animal, you carry around a balloon.
So, more water that we use H2O. That one.
No, it doesn't matter. Water in any form, you can write as H2O or HOH. If you know it's going to react, this is easier because look what it says next to magnesium. Can react with what? With water and acid, replacing hydrogen. If I read it like this, watch what we're saying happens. Magnesium come in here
Get this out of
and
your
knock off hydrogen. Now watch. See if this makes sense. Doesn't that mean now that magnesium is going to react with OH? Now think this through. If I react magnesium with OH, now they're becoming a compound, right? So doesn't magnesium become Mg2+?
Yeah.
And doesn't hydroxide stay as OH minus as it always does?
Yeah.
So when I then balance them out, doesn't that give me MgOH parentheses 2?
Yeah.
Plus, didn't this hydrogen get knocked off?
Yes.
So when it gets knocked off, we still have to write it as H2. Because remember, hydrogen is part of alcohol. So this is the overall reaction. Now, I normally would just jump to the ending because in all cases, you're going to form magnesium, you're going to form a hydroxide, and you're going to form hydrogen. Magnesium hydroxide plus hydrogen. Yeah. Now, we did this. Water. In lab, didn't we, instead of using water, didn't we use HCl? Now, how is that any different? Well, look at the wording of magnesium. Does it can react with and acids replacing hydrogen? So in this case, this is what we did in the lab. We took magnesium and we put together with hydrochloric acid. Well, if you take a look at this is a single replacement. You have to use the word. Magnesium can come in here and do what? Then knock off the hydrogen and then react with Cl. Again, when we're reacting two things together, by itself is an Mg. But when it's form a compound, does it become Mg2+? So in that form Mg2+ and Cl-, in that form MgCl2 plus, when this hydrogen gets kicked off, it would again become H2. Does this look familiar with what we did in the lab?
Yes.
That's a single replacement. Now, here's the thing. Just like every single replacement attempt, you've got to look at the words, and if you're in the third or the fourth group down below, give me something from the fourth group, the sad little fourth group. Copper, whatever. If you try to react those with water or an acid, what's next to them in words? Nothing. That means they can't react with them. So you can only do what's next to you and below. And understand, you only use the words when you see react, and the problems they can say a metal plus, and then one of the compound either water or some form of water and an acid. Other than that, you just go to the regular single replacements. Any questions? Okay, that was a lecturette on that. Now,
I found my little